Stylus. Okay, so the chapter 6 opener is due tomorrow by 2:30. There is no work paper for that one. Not saying that you couldn't have done work. They probably used a calculator, but it's almost pointless to have you write down the work when all you have to do is plug in an answer, plug in an X to get a Y. Okay. The reason we worked on that is because this chapter is all about functions, and functions have an input and an output. They have an independent variable and a dependent variable, and those are vocab words we're actually going to look at today. Camden?
Will there be some homework stuff with the work paper? Like that?
The homework from tonight, you won't need a work paper on. The rest of them you will, at least for the rest of this week. So 6.2 and 6.3 for tomorrow and Friday, you will need a work paper on, okay? If you have not done so already, please download the 6.1 notes, wrong class, off of Google Classroom. So you're ready to follow along with us. So if we go back in time to even before Christmas, we spent a lot of time on this chapter about linear equations and how to graph linear equations in slope-intercept form. And then we just did a chapter over systems of equations where we can also graph those equations to see where they intersect, or maybe they don't intersect because they're parallel, or maybe they are the same line. And then what we're going to do is we're going to take that information right into chapter 6, and we're going to look at functions. And on Friday, specifically Friday, we're actually going to look at linear functions. And so we'll be writing them in slope-intercept form. So all this is going to relate to what we've already done. You might find this chapter extremely easy if you remember everything about slope-intercept form. Okay. So ordered pairs can be used to show inputs and outputs. The X variable is called the input. The Y variable called the output. The reason we call the X variable the input is because when we think of a linear, I'll just use linear equations as another example. When I think of a linear equation, like that one, it's a lot easier to plug in a value for 6 to get Y. Sorry, I said 6. I don't know why I said 6. Well, because I wrote it. It's a lot easier to plug in a value for X and get Y than it is to try to plug in for Y to get X, because it's already solved for Y. Whatever value I plug in for X, I times by 2 and or times by -2 and add 6 to it. And that's the answer for Y. So because we typically write equations in this form, that's why they call the X variable the input. It's easier to plug in. And when you plug it in, it spits an answer out for Y. Okay. So the Y is called the output. The X variable is also referred to as the independent variable. They call it the independent variable because usually you're given that X to plug in, you're given that value for X. The Y variable depends on what you plug in for X. If I tell you to plug in 3 for X, you're going to get a different answer. If I tell you to plug in 4 for X, you're going to get an even different answer. And so the Y variable always depends on what you plug in for X. So that's how I remember it. Okay, the Y variable is the dependent variable. The X variable is the independent variable. Okay, think about what that word independent means. Okay, without help, on your own, not needing any assistance. Whereas if I said find what Y is, you'd need to know what to plug in for X first. It depends on the X variable. Now, some even newer vocab words. A lot of vocab in this first couple sections. All the possible X values are called the domain. And all the possible Y values are called the range. You will use those vocab words more next year than even we do this year. Levi?
Is that like a different range than the biggest number minus the smallest number?
Correct. Yeah. So when we say range, we're not talking about the range we would use for measures of central tendency, mean, median, mode, that kind of thing. Yeah, it's slightly different. The range would be all your possible y coordinates. When we're talking about a linear function, like that line right there, that line extends on forever in both directions. So if I asked you what all the possible y values are, the y-axis obviously goes up and down. Because this line goes down, 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 down forever, and goes up, 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 up forever, you would say that the range of this linear function is all numbers. In fact, what they say is they would say all real numbers. Some people might put that, but you'd have to say positive infinity all the way to negative infinity. So if you say all real numbers, or there's actually an abbreviation for that, it's like that, like an R with 2 bars, stands for all real numbers. That's what the range would be. And again, you'll focus more on this next year. Yeah, Dylan?
So a line that's flat, would that mean that it would be 0?
Ooh, man. Okay, yeah. So we'll talk about that in just a second. Okay, let me switch to domain real quick. Okay, yeah.
Why is it called all real numbers?
Because in the number classification system, real numbers are actually one of the classifications. There are fake numbers. There are numbers that aren't real. We'll talk about them in a couple chapters. Okay.
350?
No, those are real numbers. Any number that you can think of, is real. That's not a number. I said any number you can think of. Okay. Well, you start putting letters in it. Hey, Jack?
I have 2 things. Is it a non-real number, like the square root of a negative number?
The square root of a negative number is impossible. There is no number for it. So therefore, it's not real.
And also, on the homework for today, it's not 0 when the line's flat. It's just that all the input.
Yes, I wanted to do an example of it. Yeah, it's not necessarily 0, but it's okay. We'll get to it in a second. Okay, now for the domain. The domain is all the possible x values. Again, for this line, it'd be all real numbers. Because on the x-axis, which goes left and right, this line not only goes up and down forever, but it goes left and right forever. So every possible x value you can think of all the way to positive infinity and all the way to negative infinity, you can find it somewhere on that line. Okay? Yes, we're talking about linear functions this year. But not every function is linear. In fact, we'll look at some this year that are nonlinear. You'll talk a lot about them next year. Nonlinear functions, for example, a nonlinear function might be a function that looks like this. That's called a parabola. Yep, you'll look at these in a lot of detail next year. A parabola. Yes, you remember. Good. So let's say that this parabola is right here on the x, and here's the x and y axis. Let me get that lined up a little bit nicer. Okay. So if I asked you for the domain, all the possible x values, it may not look like it, but this parabola extends to the right forever. It gets steeper and steeper, but it actually goes on to the right forever. So it extends to positive infinity and it goes to the left forever. So it goes to negative infinity. So if I asked you for the domain of this parabola, which is all the possible x coordinates, you'd say all real numbers again. Like any number works. You'll find any number for x you will find on that parabola. Okay, here's where it's nonlinear actually plays a part in that. There is a minimum value of this. What's the smallest value on the y-axis that this parabola has, Caitlin? 0. So the range, I can't say all real numbers because there isn't any negative y's. They're all positive. So what I would say is that the range is all y's where y is greater than or equal to 0, meaning not negative. They're in a single negative y coordinate. There's negative x coordinates, I understand that, but there's no negative y coordinates on that. So you wouldn't be able to put all real numbers on that. If it was just a diagonal line like the last one, yes, it would have negative values. Okay, so that's domain and range, all the possible x's, and then the domains, all the possible x's, the range is all the possible y's. Okay, now Dylan brought up a good point. What about a horizontal line? So here's our coordinate plane. There's our x-axis, y-axis. Let's say that's at 2. Okay. Does this line on the x-axis go to positive infinity?
Yes.
Negative infinity?
Yes.
Okay. So the domain is all real numbers. Okay. Does this line, like the last line, go up and down?
No.
Okay. So the range only has 1. What's the only y value that you will ever find on this line, Nuche?
Negative 2.
Well, positive 2.
Oh,
It's-
no, the
it's-
red line.
The red line, yes, the red line, not the purple one. Yeah, so it's at positive 2. And so that's literally, so I would write, I think you have to write y equals 2 next year. I don't know. If you put 2, I'd get it as well. That's the only value that works. There is no values of 3 or 4 or 5 or negatives, anything like that, because it's horizontal and it doesn't go up or down at all. It's just completely flat. Same with the vertical line. It'd have an infinite range, but a restricted domain, because if it's vertical, it's only going to have one x value all the way. Yes.
So like on this, will all the arrows be pointing towards one output on an input output?
Man, you are way too far ahead of me, Nuche.
Sorry, that was from-
I will catch up with you.
That was in the homework.
No, he's talking about tonight's homework. I'm just not there yet. Yeah. So that was a lot of new vocab words. So let's describe, let me go ahead and put these in here. The X, what are some different names I have for the X? We mentioned that the X was the input. That was the first thing we called it. And we said that the Y was the, what's the opposite of input? Output. Then we said you can refer to the X as the independent variable. I'm going to have to abbreviate variable, just VAR, so I ran out of room. And then the Y was the what? Dependent, because it depends on whatever you plug in for X, whatever you're inputting. And so again, when you did the chapter 6 opener, they had you plug in a value for X and tell what the Y was. They might even, did they have you plug any values for Y in and then see what X is? If so, you can still do that. You're just doing it in reverse. And that's why it's takes a little bit more time for those. Like if I asked you to, did I still have that question? Yeah. If I said, hey, what's the X value when I plug in 3 for Y? Well, you got to think, okay, I got to solve this for X. It's already solved for Y, so it's going to take me some work. You got to subtract 6 over to make it -3, and then divide -3 by -2 to get +3 halves, or 1.5, and that would be the X value. So you can do it in reverse order, it just takes more time. It's a lot easier to input and output than it is to output and input. Yes?
Once ST starts, can you go over the bonus question on yesterday's lesson?
Yes.
Thank you.
Well, actually, Mason has not finished it yet, so say tomorrow. Yeah. Yeah, right, Mason, we're gonna get that turned in? All right, we also said that the X was all the X values were the domain, and all the Y values were the range. I don't even think I asked you a whole lot of domain and range questions on this year's homework. I think most of those come in next year's. And then there's one more thing. I just threw this one as extra. We refer to the change in X as the run, and we refer to the change in Y as the rise. And so, yeah, we use rise over run for slope and all that stuff. And every linear function has a slope, even if it's undefined. Lines have slopes. So, all right, so let's talk about a relation. A relation is a fancy way of describing a series of ordered pairs. So a bunch of points. Okay. So a relation pairs inputs with outputs and can be represented by what they call a mapping diagram. This is a mapping diagram. It takes the 3 points they gave us, and it says when x is 0, when I input 0 to my equation, it's going to output a 1. So when I plug in 0 for x, y equals 1. When I plug in 1 for x, y equals 2. When I plug in 2 for x, y equals 4. It's interesting that they give us this example. Yeah, Dylan?
Because it's a function.
It is a function, but there's something interesting about this function. Remember we said x is the change in x is the run, and the change in y is the rise. If it's a line, what kind of slope's it going to have? Maybe that's a bad way of asking the question. What will happen to the slope of my line? Maybe that's a bad question. Is the slope of my line constant or variable? Is it changing or is it always the same?
Well, it depends.
Of a line.
Oh,
Is it always the same slope or does it change?
Always the same.
Always the same. So lines have a constant rate of change or a constant slope. And so if you look at your rise over your run here, when you rise 1, you run 1. So the slope of the first 2 points is 1 over 1 or 1. When you rise 2, you still run 1. So the slope of these 2 lines is 2 over 1 or 2. And it changed. It's not saying this isn't a function, but I am saying this isn't a line. Because if it was a line, it'd be the same slope every single time, it'd be constant, and it's not constant. We call that a variable rate of change. That's what a parabola has. A parabola, if you look at one side of a parabola, it starts off kind of not so steep, and then as you go up the parabola, it gets steeper, steeper, and steeper. Your slope keeps changing. The rate of change changes. That's kind of an interesting way of thinking about it. It increases at an increasing rate. Make sense? It increases at an increasing rate. We agree that the slope is positive, but it's not constant. It starts off slightly positive, more positive, very positive, even more positive, and it just keeps getting steeper and steeper. For example A, they want us to do 2 things. They want us to complete the mapping diagram. Well, they asked us to do 1 thing. I'm going to ask us to do 2 things. I want us to write a function for this. And so my area function, who can tell me, geez, not everybody at once, how do I find the area of a rectangle? Dylan. Okay. So my function is A equals length times width, but specifically for this rectangle, the length and width would be 2 times x or 2x. Yeah. So there's my function. Whatever I input for x, times it by 2, and that gives me the area. Does that make sense? So what if I plug in 1 for the length? By the way, if I plug in 1 for the length, we wouldn't call it the length anymore because the length's supposed to be longer than the width. But let's say I plugged in 1. When I times it by 2, what's that give me for the area? 2. You can all just say it. What if I plug in 2 for x? 4. What if I plug in 3 for x? And what if I plug in 4 for x? It's as if every time I increase the x by 1, it increases my output by 2. Because my slope is 2. If I were to graph this as a line, y equals 2x, you have a slope of 2. So it's linear. This would be a linear function. Perimeter. How do I find the perimeter of this rectangle, AJ?
2L plus 2X.
Okay, that's the perimeter of any rectangle. What about this one in particular? You might have said it. What did you say again? 2L plus 2X? Don't use L. What is my length, AJ? Okay. So that's my width. Can I call that my width instead? Okay. So when I plug 2 in right there, what's 2 times 2? 4. Okay. But I still don't know what my length is. Let me call that x then. So that would be P equals 2x plus 4. You guys tracking on this? Okay. Hi. Sure. Yeah.
Thanks, guys.
They do those? They have those? I think we need to just.
Logan Wonderland and Enon Hightower, please come to the office. Logan Wonderland, Enon Hightower, please come to the office.
Yeah, that bird was I know. That was
Okay. Sorry about that. Fast forward to here. All right, so 2x plus 4. I'm multiplying the x by 2. Now, if you're wondering where this came from, it's because it has a rectangle has 2 lengths and it has 2 widths, and of course you have to add all 4 sides together for a perimeter. And so x plus x is 2x, and 2 plus 2 is 4. And so this is also linear. Okay, it's also linear. And it's also got the same slope of 2. So every single time I plug in a value for x, the next one is going to increase by 2. So when I plug in 1 for x, 2 times 1 plus 4, 6. So it starts a little bit higher, right? Perimeter typically bigger than area just because there's more, at least when the rectangles are like this. If I plug in 2, it's going to be 2 more because I've still got 4, but I'm adding 4 on, so it's make 8 now. And then what happens when I plug in a 3? 10, and what plug in a 4? 12. It kind of seems like almost what you were doing in the chapter opener, where you just kind of plugged the value for x and got the y. Of course, we're doing it 4 times right now. AJ? Not add 4, but add 2. The 4 is the y-intercept. Ah, I see what you're saying. Yes, you could. Because the 2x from here is just getting added 4 to it from right there. Yeah, you could. I didn't even realize they were the same rectangle because they use different colors. I kind of thought they were 2 different rectangles. But yeah, you're right. The 2 is the width and the x is the length again. So yeah, you could do that. Circumference. How do I find the circumference of a circle? Caitlin?
Wait, no,
That's area.
Pi d.
wait. But I have it somewhere in there.
I'm sure you do.
Oh,
I lost my.
All right, Nuche, what is it?
okay, yeah.
Pi d.
Pi d. Caitlin, you were very close. You could say 2 pi r.
Can we say d pi?
Yeah,
D pi, that sounds weird.
sure. Typically, we put the coefficient in front of the variable though. And since pi is a number, we put it in front. 2 pi r, because the diameter is twice the radius, if they give you the radius, obviously you have to times by 2. And so I'm actually going to use this for my formula for this circle, because this circle gives me the radius. And so my function is going to be c equals 2 pi r and not d, just because they're not giving me the diameter. They're giving me r as my letter, so that's the radius. And so when I plug in 1 for my radius, you want to use this formula, that's fine, it gives you 2 for the diameter. But if I plug in 1 for the radius, I times by 2, and that gives me 2 pi. I do not need to write it as a decimal. I can leave it in terms of pi. When I plug in 2 for r, what's that give me for the circumference?
4
4 pi. What about 3 for radius? And if I plug in 4 for the radius? All right. You guys are good with functions. What about the volume of a rectangular prism? Heard from you already. Olivia? Length times width times height. So for this particular prism, length and width are both 3. So what's 3 times 3? So for this particular prism, I would do v equals 9h, because length times width times height is 3 times 3 times h, which is 9h. Mason? Capital B times h? Yes, that's what we would have actually, that's what I told you guys it was earlier in the year. Capital B times h. That volume formula works for any prism. And then specifically for rectangular prisms, your capital B becomes L times W. Yep. And so if I plug in 1 for h, it's 1 times 9, and then 2 times 9, 3 times 9, 4 times 9. Yeah, so if I were to graph this on a coordinate plane, the slope is 9. It's a lot steeper than our last ones we were looking at, so it's increasing at a faster rate. And volume does that. Volume is going to increase more than what the area or circumference of a circle would. All right, let's get into some new stuff. It says, list the ordered pairs shown on the map. Oh, this isn't not new, sorry. List the ordered pairs on the mapping diagram. This isn't the new part, but we'll get to the new part. So the first coordinate point I would write here, when x is 1, what is the y value? 3, okay. This is not meant to be a trick question for this one, all right. What's another point on my line? 2, 6. Now I say it's a line because plus 3, plus 3, plus 3, plus 1, plus 1, plus 1. My slope's always 3 over 1 or 3. So I know it's a line, it's always constant. Some functions aren't lines, but this one is because it has a constant slope. What's another point on my line?
390.
And the last point that I know is on my line. Okay. And I could do 5, 15, and I could just keep going, but we'll just list only the ones they give us. Okay. Now this one is interesting. Follow the arrows. When x is 0, what is y? Good. When x is 2, what is y?
Y or negative? I mean,
1 or negative 2. Interesting. When y is, or sorry, when x is inputted as 4, what is the y output as?
Negative.
Okay. Still 4 points. This is not a function. Not because it's not a line. It's not a line. But like I said, some curves, right? Some the functions will curve. This one's not a function because, little definition below here, a function is a relationship that pairs each input with exactly one output. And you can see that in example B, this input was paired with 2 outputs, making it not a function. Olivia?
So if you look at example A, if instead if it was 3, 6, or 12, and it was 12, 9, 6, 3, would it be like 1, 12, and then I thought it was going to be negative. Sorry to confuse you.
It's not negative because as the x increases, so does the y. So positive x, positive y, positive slope. Okay. If one of them is negative, then it would be negative. So if they're both negative, it's still actually a positive slope. Okay. But in this case, it would be positive. New check.
Correlation between a function can also have, can an output have multiple inputs?
Yes. Yeah. In order to, when we say that a function pairs each input with one output, it does. We don't have to reverse that statement around and say that each output has one input. Some outputs will have more than one input, and that's okay. And I'll show you an example of that because I've got some here listed. But what I need to do before I do that, I need you to scratch this out. I started to write this and then realized I wasn't going to have room to finish the sentence. And then I, for whatever reason, didn't erase it. Not every function is one-to-one. This function is one-to-one. But the function that Nuche just described, where there's actually more outputs than inputs, that could still be a function if so it just wouldn't be a one-to-one function. And so scratch that out because I don't want you getting confused by that. I meant to type that in, realize it was going to bump everything down. I wasn't going to have space on my thing for the next. I guess I could have gone to the next page, but I, for whatever reason, didn't finish the sentence. So that does not apply here. So let's just scratch that out. Okay, so it says determine whether it's a function. This is why you don't have a work paper on tonight's homework, because these are just yes or no's, and I'm not going to make you draw the mapping diagrams. So you'd literally just be writing yes or no, function or no function. Let's look at example A. When I say that a relationship pairs each input with exactly one output, that means if you're looking at a mapping diagram, this is a no-no. You can't have 2 arrows coming out of the same input. That's a no-no. Now, if you have something like what Nuche described, where let's say the list of X, you've got 2 and 3. I'll just list 2 of them. And for the Y's, it's -3 and -3. You look at that and you're like, whoa, 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 there's more than one output. But is there only one arrow coming out of the 2?
Yeah.
One arrow coming out of the 3?
Yeah.
So it's a function. Hello?
Oh,
Yes. Hi, Mason Cooper, go see Mrs. Deweese. It's only when it looks like this that it's not a function. Okay, so one input going to 2 different outputs, that's bad. Two inputs going to the same output, that's okay. That's okay. That's still a function. That's okay. You know what it looks like? It looks like this. What do we call that shape again? Parabola. So here's what I mean. This is 0 on the x-axis, okay? Let's call this -1 on the x-axis. When x is -1, the y is 1. When x is +1, the y is 1. You can have 1 or 2 different inputs going to the same output. That's okay. You can't have, so if this is good, this is an example of what's bad. You can't have 2 arrows coming out of the same X. Okay. That's kind of confusing. Dylan?
How could that be a parabola if there's only 2 points?
Oh, there's more than 2. I was just using 2 as an example. I was using, as an example, I was using this point and that point. When x is -1, y is 1. When x is +1, y is still 1. So two different x's go to the same y value of 1, and that's okay. That's the example of two different x's going to the same y. That's okay. If the same x is going to two different y's, that is a problem. Okay. So let's look at these mapping diagrams, and I know that's new, so I've got several examples for you guys to look at with me. Do you have any inputs? How do I phrase this so I can say it right? Okay, let's just look at the arrows. Is there a number, is there an input that has two arrows coming out of it? Okay, so this is a function. Maybe that's the easiest way to ask yourself. Yeah, there's two inputs going to the same output, but if they each have their own arrow, I don't care what they point to. Okay, you can go to the same output. That's fine. You just can't come from the same input. That's bad. Example B. Any of those inputs have two arrows coming out of it?
Yeah.
Which one?
Zero.
Yeah, that right there, not a function. So from now on, I'm just going to put yes or no, now that you know what we're actually looking at. Caroline.
So if 0 was normal and there wasn't two arrows going out of it, would 2 and -1 input be fine if the arrows?
Yes, it would be. Even if they cross, they still just have one arrow coming out of it. So that would, so if this number was not there and so that arrow was gone, that would still be okay. Yeah, that's a good question. Any inputs with two arrows coming out? Yep, so this is not a function. I'm just gonna put no. Okay, right there. All right, now this one, they switched on us. They're not giving us a mapping diagram. They're giving us what I call a t-table, where it kind of looks like a T, you got X's on one side, Y's on the other side. So when I have a t-table like this and there's no arrows, I can't ask the question, is there one arrow coming out or two arrows coming out of the same X? So here's, if I'm looking at a t-table, here's what I ask myself. Are there two repeating X's? Yes. Do those two repeating X's have the same Y or two different Y's? Then that is a problem. So imagine this would be like saying 2 goes to 5 and 2 goes to -1. That's if I drew it with arrows. So this is definitely a no. Nuche?
It has the same one.
It's got to have, you're right, it would have to have the same Y.
So,
Yep. I've got an example like that. Let me get there.
now, why would I like two things with the same one? Why would I waste the-
Next t-table. Shush, Nuche. Any repeating X's? So there's no way you could have two arrows coming out of the same X, right? If there's no repeating X's, I'm even going to write that. No repeating X's. That's how I know this is a function. There's not even a chance. Here, there was a repeating X right there and right there. You might even want to circle those in your notes. So I know that's not a function because it goes to two different Y's. All right. Example F. All right, Nuche. Are there repeating X values here? Yes. Do they go to two different Y values?
No.
No, it's the same point. So this is a function. Or I guess you put yes, this is a function. It's like 4 going to 3, and then me drawing the same arrow and saying it goes to 3 again. It's the same point. Okay? It doesn't, if it's not a function, that means it has two different outputs.
Oh, so it's like 4. Oh.
Has the same output. Trick question. This one is a function. Has the same output. Yeah, it's listed twice. It's the same point though. Caroline?
So if you were drawing it in the other kind of charts that were like on the sheet,
Yes.
would you put it down there twice or would you just leave it once?
They wouldn't even put it down there twice. They would just have it once. And so you wouldn't even notice. You wouldn't even notice. Olivia?
So if you go up to like, number D, and if one of the twos were negative, would it be a function?
Yes. Good question. She says, whoa, what if this is -2? Then I have no repeating x values because -2 is different from +2. So if this was -2 and that's +2, there's no repeating x's. There's no way that this is going to be a two different outputs for the same input. So you would say that's totally a function then. Okay. It's only when the input repeats and goes to two different outputs. So that happened here. So this is not a function. I wrote the word no, but not a function. Okay. This one is a function because yes, the input repeats, but it's going to the same output. They just put the same point. It's like, okay, there's the point on the graph, and then I want you to graph it again. It's the same thing. It's not going to two different outputs. Okay. Let's answer these, and then I have one more thing I need to mention that will show up in an IXL. So I need to mention that. It says, describe the pattern of inputs and outputs in each mapping diagram. Is the function linear? Here's what they want us to do. If it's linear, they want us to write it in slope-intercept form. Okay? So, number one, is this linear? Is the output increasing by the same amount as the input's increasing by?
No.
Sorry, I said that wrong. Is the change in y over the change in x constant?
Yes.
Yes, so this is linear. More specifically, what is the change in y? What are we adding to the 15? What are we at each time, right? What are we adding to the x each time? So that 15 over 1 reduces to, okay, so my equation would be y equals 15x. Does it start at 0? Let's back up 1. Because remember, the y-intercept is when x is 0. So if I back up 1 and subtract 1 to make this 0, I have to subtract 15 to make this 0. It does go through the origin, and so I don't put a number there. It's just y equals 15x. I don't need to put plus 0. So that would be the linear equation of this function. Let's look at the next one. Y increases by 3. Oh, sorry, decreases by 3. That didn't look right. Decreases by 3, decreases by 3, decreases by 3, as the input increases or decreases? Increases by 2, and by 2, and by 2. Because it's always the same change in y and the same change in x, I know this is also linear. What is the slope of this line? -3/2. Change in y, the rise is the change in y. Remember we do y2 minus y1 on top? Not that we don't put the x number on top. So the change in y was -3. The change in x was 2. So -3/2. Okay, they're not both negative, just one. If they were both negative, I'd actually write it as a positive. Okay, does it give me the x being 0?
No.
Gives me the y being 0. I don't want that. Okay, so -2 becomes 0. Add 3 becomes, my y-intercept was a 9. So -3/2 x plus, hit the wrong button, plus 9. There we go. Okay. So the last thing, and I know I'm holding you guys over, but some of you I know are already even asking about the IXL I posted today. Okay, because we have a new list of IXLs for chapter 6. And one of the IXLs is asking about functions and is it a function or not. And they're going to mention something called the vertical line test. So I want you to write this in your note. Vertical line test. From now on, abbreviated as the VLT, vertical line test. That is how you tell visually if you have a function or not. So if I were to graph points from here, there, and there, does that make a line? No, but I don't need it to be a line to be a function. To tell if it's a function, if I can draw a vertical line anywhere on this and it crosses my function twice, that's bad. Do any of those vertical lines cross my function more than once? Nope, so this is a function. It passes the vertical line test. Okay. What about this function or possible function? Could I draw a vertical line that would cross that image twice? So it's not a function. Now, I actually could draw a line that only crosses it once. If I drew it right there. But if I can draw any vertical line that crosses it more than once, it's not a function. So how does that relate to the whole mapping diagram stuff we were doing before? Let me find one that wasn't a function. This one was not a function. Copy paste. Let me show you what this would look like and why it wouldn't pass the vertical line test. Okay, let me do a quick sketch of a coordinate plane. Don't want to take any more of your time than I have to here. 2, 5, 1, 2, 1, 2, 3, 4, 5. There's the first point. 0, 8, 6, 7, 8 is right close there. 2, -1 is right here. And then 4, 3. Okay, so let me go ahead and draw and connect these real quick. Can I draw a vertical line that will cross that function more than once? Good. Good. Bad. So when I, no. When I said that you can't have this stuff going on, right? You can't have two arrows coming out of the same X. What that means is when I graph the points, they're right above and below each other. And so when I connect them, I have to draw a vertical line. Well, a vertical line is going to cross a vertical line, obviously right there. So this does not pass the vertical line test. If they would have moved that point over one spot, I'd been okay. And I wouldn't have had any repeating X values. They all would have gone to different Y values. Okay, so that's what a vertical line test. Let's do some cool sketches. This is the graph of sine X. Does it pass the vertical line test? Yes, it's a function. Okay. This is the graph of the square root of X. Does it pass the vertical line test? It's a function. Okay. By the way, the graph of the square root of X, I don't know if you noticed that, it's a parabola tilted on its side. You know why the other side's not there? Because if I drew it, would it be a function? No, it wouldn't pass the vertical line test. Also, Nuche, what did you say about when you square root a number? Can you ever have a negative answer? It doesn't even exist. That's why. You can't square root a negative number. Because square rooting is the opposite of squaring. When you square a number, it's always positive. What's the square root of 2? What's the square root of -2? -2 times -2 is, it's never negative. So you can never have a negative value on this, which is why it's not there, and which is why if it was there, it wouldn't be a function because it wouldn't exist. You'd have a problem, okay? So if you get an IXL where they ask you if it's a function, and instead of giving you a bunch of X's and Y's, they give you a graph, that's even easier. Use the vertical line test, and you can tell visually if it's a function or not, okay? What about that? Is that a function? Nope, doesn't pass the vertical line test. So it's not a function. Caroline.
Some of them until they started doing this.
Hmm,
But then
okay.
they had some really random thing when they started doing horizontal lines and said that was also a thing, but I didn't really understand
Okay,
that.
here's a horizontal line. If I draw a vertical line anywhere on this, does it pass it more than once?
No.
So
but
horizontal lines would be functions.
I'm like saying that they would take instead of vertical line test, they do horizontal line test.
Okay, the horizontal line test tells whether, remember I had you scratch out up above in your notes 1-to-1? That tells you if it's a 1-to-1 function. It doesn't tell you if it's a function, it tells you if it's a special type of function. We're not going to talk about that this year. Okay. All right, we're done. Bathroom empty?
Yeah.
Looks like it. Go use your restroom break. Sorry, I ate into your class time, but if I didn't cover that, I was going to get a whole slew of questions, and I just knew we needed to go over that.